Hello, Professor. I'm going to show you my homework number two. This is going to be a controlling two leads their intensity using an ADC control. In this case, we're going to use the potentiometer, and the potentiometer will allows us to control the voltage. It will do the or leads getting bright and dimmer. Every time that we bright one of the lead, the other one is will be timer. Is if we put it under 50%, both are will be in the same intensity of voltage. Okay, so starting we're starting with the IOC. We're gonna start programming. The first thing we will start programming our ADC one. I'm gonna move this to here. All right. So we're starting setting our ADC one. It will be in our pin zero in zero, and then we're gonna start saying everything will be disabled or set using ADC will be disabled. So the thing we're gonna change is the conversion selection will be the all flags and the all conversions. All right, so we're gonna set two timers and two timers. Actually, we're gonna start setting a clock source with our turning clock. And our channel two and channel one will be our PNW generation channel one. The one will be channel two, the PNW M. It allows us to control the voltage that will be going through to the leads. All right. So in our preschedule, we set it on zero. And 16 bits value will be on zero, or counter period will be on 25. And auto reload will be in disable. Okay. And then the homework always asks us to display or percent of voltage in the of our potentiometer as a message in the build console. Okay, so we need to set a UART, and the UART will be a UR2. In UR2, or mode will be asynchronous, and also harbor flow control will disable. We're gonna set the bound rate of 9,600 bits per second. And yeah, everything will be as a default. We're gonna set here in our chip or pin. You can see the PA0 will be ADC1 AM0, or pin A1 will be our channel 2, and also your PA5 will be our timer to channel 1. We're not using PO2, PA3 because it's this only used for your functions. We need to set our clock configuration. Our clock configuration will be in 80 megahertz. This is fine. And then we're going back to our main and C. I already generated my code, so this is my code generated. I'm gonna start explaining my C code right here. In all my C code, I include my both libraries, the Studio H and the String H. All right, and here I just create a int function which allows us to transmit the message of our messages, just setting the URL right here. Okay, this is pretty much this function right here. We're going to our main program. In our main program, we're gonna start setting our PNW. We're just starting our both channel one, channel two. PNW, we started creating uh, uh, the necessary variables to our program to make it easier to work with this with. Where ADC value, we're starting on zero, will be our raw ADC value is 0 to 4095. We're using this value because actually we're not using as any kind of prescaler. It will be just as a default the 4095. So we started setting our duty class for channel 1 and channel 2. This is your duty class for channel 2 and channel 2. And also a variable for IR with your timer auto reload value. This will be all percent. This percent will be this percent will this the variable will be displayed on our in our build console at the end. Uh, the AR we wanna set auto reload value. This is what we use to control or second lead to actually make it a dimer or going backward every time that we incrementing one of the channels or one of voltage in our lead. Okay, going to our while loop. We're starting our ADC. ADC will be in this function. The HAL ADC starting HAL C1, HAL ADC starting ADC 1. Okay, so this is actually well, that was something that actually I can remove, but it will stay there. Okay, so we started our DC conversion. Also, we need our pole for conversion, the DC1 with a held maximum delay. This is the function we until the conversion is complete. Our DC value, we get our value from our ADC. This is the duty class for the channel 1. This is will scale ADC value to PNW. So this is actually, this will control, or this is calculating or duty class for the channel 1. We will do the same for the duty class number 2, but this is the case that we're using our AR. We already set up as a our time error load. It will be decremented by our duty class 1. This is makes sense because every time that we turn, we incrementing 31. So in the case that we incremented the duty class 1, duty class 2 will decrement because we will start from our maximum voltage that our lead can be capable to do. So we'll decrement. Okay, so now we're using our functional halt time set compare for channel 1 and channel 2 using our both duty class. This will update our PNW duty cycle for lead 1. Also for the second one will be updating our PNW duty class. Now we need to get our percent voltage. We're having 0 to 100%. So we're using just a regular function for getting percents using our duty class, our first duty class, multiplied by 100% divided for maximum voltage will be AAR. We need a message for building console. So our printf we print our potentiometer to equals to the percent. We're using a high delay of 100. We're using a high delay of 100 because I think it will be more accurate to use it in our building console. All right, this is pretty much what I did. And let's see if I need to run it or it's already on the display right here. Okay, so there's no any. I already built my project. I want to build it right now. This is displaying our potentiometer with 100 milliseconds delay. I know it should be a way to just activate the UR message as you just activate the console, but in this case, I just put on or while make it a little bit easier. Okay, so I'm gonna start showing the board. In the board, I'm gonna change my screen right here. Sorry, if it's like that. Okay. So here I have for the potentiometer. So in this case, you can see it's 48% right now. So both leads, they are the same brightness right now. So if I turn it for 100%, let me change my hands so you can see that. So if I turn it for one side, one gonna get brighter and the other will be dimmer. So one of those is completely off and the other one is on. If I change it to the other side, we'll do the same function but the other way. Okay, so now just want to show you the building console. So the building console is thinking of posimeter right now. So it's just the posimeter is going just in one way. We say this is 96%. If I'm going down, it will decrement our percent of our duty class one. This case is the duty class one. So the duty class one is going in this case is zero, but in our channel two, the channel two will be in 100. So it will be the higher one. Okay, so this is it. Thank you for watching, and this was my homework. Thank you.